Okay, Mr. Muhammad, we will start. Hello, everyone. Today is the 19th of August, 2024. Society of Petrophysicists and Well-Log Analysts, SPWLA IRAQ Chapter would like to welcome you. We are thrilled to have you with us today. My name is Mohammed Zainullah Abedin, VP of Technology at SPWLA IRAQ Chapter and Senior Faculty Member at Petroleum Engineering Department, College of Engineering at University of Kirkuk. And I will be your host for this session. Please, Mr. Mazen, the president of SPWLA IRAQ Chapter, you can join with us.
Hello, everyone. Is my sound clear? Dr. Mohammed? Hello? Hi. If my voice is clear? Okay.
Yes,
Now
yes.
I can. Yes,
Okay.
now I can hear you. Now I can hear you back.
Okay.
Okay, because I wasn't hearing anything. So I would like to welcome all our attendees today. It will be all a pleasure to host you all. I'd like to thank our presenter, Mr. Mohammed Alsmael, for his volunteering and get his time to support this technical activity. And I also like to thank Mr. Mohammed Zain Abedin, our VP of Technology, for all his support to organize this event. Hoping will be a successful event, and thank you all.
Dear attendees, in 2024, SPWLA Chapter Iraq theme is to focus on production logging. The sixth webinar in 2024, PLT interpretation utilizing Techlog software of SLB company, will be presented by our speaker, Mr. Mohammed Alsmael. Before we get started, just a few quick housekeeping items. If you have any questions during the presentation, please type them into the Q&A box and we will address them during the Q&A segment at the end. Also, this session is being recorded. For your information, we have a cooperation, I mean SPWLA IRAQ Chapter, with some oil companies like SLB, Baker Hughes, Kappa, TGT, and others for this year, 2024. And in addition to Super Learner Special Certificate will be presented to attendees of 6 webinars in December 2024. Please, if you are a member in SPWLA chapter, you can change and it's preferable you change your location to Iraq chapter if you are working in Iraq oil industry. In addition to, during the presentation, we will send to the chat box the link which can help you to join SPWLA IRAQ chapter on LinkedIn. There will be a certificate of attendees and it will be sent to you within 3 days. We hope you have a great time during the webinar. Please join me in welcoming Mr. Mohammed Alsmael. Mr. Mohammed Alsmael, you can introduce yourself in detail. The floor is yours.
Okay, thank you, Mr. Mohammed, and good afternoon, everyone. Hello, everyone. Thanks a lot for joining us today in this webinar for Society of Petrophysics and Well Log Analysis. So this webinar will be focusing, as Mr. Mohammed mentioned, it will be focused on the production logging. First of all, I would like to thank Mr. Mohammed and Mr. Mazen for organizing this webinar for the production logging utilizing Techlog software. My name is Mohammed Alsmael. I'm borehole petroleum engineering lead, working with SLB, responsible for analysis and interpretation of production logging, well integrity, and reservoir engineering as well. I will be sharing my screen to go through like a quick introduction about the PLT and also for the production logging suites inside the Techlog software. So just please let me know if you can see my screen. Just please type in the chat if you can see my screen. Okay, thanks a lot for your confirmation. So this is the webinar. As mentioned, it will be focused on the production logging utilizing the Techlog software. The agenda for today, I will go just quickly, very quick into the introduction of the production logging. What is the production logging and why we are using the production logging in very basic manner. Then I'm gonna jump to the Techlog production logging, the software inside the Techlog, which is the modules or plugin. Then we're gonna go to the software and do some kind of the interpretations inside the Techlog. So as you know, the production logging, why we are using the production logging and what is the production logging? So basically the production logging is the tool or measurement that we are using in our wells in order to monitoring the production, injection, and as well as for the well diagnostics. So all these, we're gonna tell us what are the type of the fluid that we are producing. So in case here, for example, we have like two perforations, we're gonna know what type of the fluid that, for example, perforation number 2 or formation number 2 here is producing, and how much exactly is producing. Then, and what is the contribution out of the total production is producing for the each formation or each production. And if we have, like, for example, one formation, we're gonna also know what's part of that formation is producing more. Is it the lower part? Is it the middle part? Or the top part? So we're gonna know the type of the production, and then where is the production is coming from. The type here, it's meaning like either to be oil, gas, and water. And the last one is how much we are producing, how much in barrel per day or any units, how much we are producing from each type of fluid. So here it's just the basic definition of the production logging tools and why we are using this kind of tools. So here, it's one of the objective of the production logging is to see the contribution, either to be for the production or the injection. Even if we have the injector wells, we can run the PLT with a specific configuration of the PLT to know the injection profile inside our wells. The second one is also help us to identify if there is any, for example, cross flow between the formation, if we have higher permeability with a low pressure, and also if we have any leaks inside the casing, we're gonna see it clearly in our PLT or the production logging tools from specific sensors such as like spinners, as well as if we have like a flow behind casing, we're gonna have an indication of having that flow behind casing, not from like all the sensor, but from the specific sensor as well. So this is going to help us in order to identify, for example, the intervention of plan if we have such an issue inside our wells. And the last one is for the well testing. For example, if we have a BLT data for one well, it's recorded in multiple choke size, we can have the selective inflow performance in order to identify the pressure and the rate, the optimum rate that we are planning to produce. And also we can use the BLT as it has the pressure measurements. We're gonna like have like kind of, I would say, stations. We're gonna stop the tool at a certain depth and record the pressure till we have a stabilized pressure. Then we can do also the pressure transit analysis. So all these we can do it with the production logging tools. So how it looks like the production logging tools. So this is the production logging tools, the BLT. And the thing here, it's the definition or the name of the BLT. It might be different from like a vendor to another. So the first one, I would say, starting from the BFCS. Here, it has the caliber, 4 arms. Each arm, it has here the E-probe. Each arm it has the E-probe. What E-probe? It's the electrical wattle hold up. It's gonna measure what the hold up per cross sectional area. Sorry. Sorry, just electricity issue. So just let me know if you can see my screen again. Okay, thanks a lot for your confirmation. Okay, so here it's basically the tool for the here the tool for the BLT. It has the first of all, it's the BFCS. It has the calibers, and each caliber in the forearms. It has also the electrical probe. Its working depends on the conductivity. Basically, it's the water is conductive, and the hydrocarbon it's not conductive like a fluid. So basically, it's gonna differentiate us from the water and hydrocarbon. If we have a hydrocarbon or if we have a water. Just to see your messages. Okay. So this is the first one. The second module that we have here is the BGMS. It's all, as I mentioned, also the names of each modules can be different from vendor to another's. Here is measuring the density inside the well bore. Also, it also measuring what the deviations as well. So the deviation versus the density. Why is the deviation? Because here the gradual manometer or the density module is gonna correct the density versus the deviation of the well bore. Because these tools is working basically depends on the pressure difference principle. So here it has a limitation, I would say, for the deviation. So if we have, like, for example, wells for deviation more than 60 or 70, this tool it's gonna give us like unrealistic density measured. This is a kind of the limitation. That's why, as you know, in horizontal or high deviated wells, they will not use any gradual manometer or the density measurement. Instead, they're gonna add, for example, extra water holdup or extra another sensors. For example, in the horizontal or high deviated, or they're gonna go with a full flow scanner, for example, for the FSI that designed for such as these conditions. The third one, which is the gas holdup. From the name of it, it's going to measure the gas holdup per cross-sectional area. Also has like 4 arms. Each arms has op probe, which is the optical probe. Depends that working depends on the refractive index. Then the fourth one, which is the BPMS. This one, I would say, like, it's mandatory for all the BLTs. We cannot go with any BLT without these modules, which is the basic measurement sound. It has the gamma ray, CCL, as well as the pressure and temperature. Okay. Okay, so there are also like an extra modules for the BLT. Here it's not mentioned, but it can also like add it to the BLT string, such as, for example, the inline spinner. That's highly recommended in high rate environment and the injections. All these like modules like always run it in the BLT. The answer here, it's not. Basically depends on the objectives of the BLT and also the wall bore condition. For example, if we have like a multi-phase, 3-phase, if there is a gas, if there is no gas, if there is no gas, so no need for the ghost, we're gonna go with the BFCS, gradual, and the PBMS. That would be enough. So here, basically, it's what we are aiming. We are aiming to have the velocity, the density, and from the density we can also know the holdup, the pressure, temperature, and the gamma ray in order to know that we are on depth. In order to have not only qualitative measurements, but have an only quantitative, not only qualitative, but also a quantitative measurement that's gonna answer how much we are producing or injecting. So here, the workflow for all the BLTs that we are going to do it in order to end up with the rates for the quantitative measurements. So here in the BFCS, here that we had the 4 arms, and here that we had this one is the electrical probe, 4 electrical probe on each arm, and in the middle there is the spinner. And from this spinner, from this spinner, we can have the quantitative measurement. Without it, for sure, we cannot, because this one is gonna basically measure how much we are producing or injecting, along with another sensors that we gonna combine together to come up with the total rate or the rate for each phase. So, but does this spinner give us like directly the velocity? No, it's basically this spinner, it's rotating. So the output it's gonna give us, it's the RBS or the rotational. Okay, so what we need to do is to convert this RBS into the apparent velocity, which is this one, apparent velocity, using what we call like a spinner calibration, that we're gonna do it in the software. Then, like this one, these two steps, the software does it for you. Then we're gonna correct the apparent velocity, depends on the type of the flow, either to be laminar or tubular, just by multiplied it by the correction factor in order to have the mixture velocity. Then from the mixture velocity now we have, and we have also the ID from the caliber that already measured the well bore. Then at the end we can have the total rate, the total rate that we are producing. Then by having kind of the correlations, and here in the correlations, we need to know the holdup for each phase, either to be oil, gas, and water. Using a kind of the correlation, we can estimate, or we can know I would say, the velocity of the water, oil, and the gas. And then at the end, we're gonna have the rate of each phase. So this is I would say, like the workflow that basically every engineer or every interpreter is using in order to end up with the quantitative measurements for the BLT. Now we're gonna talk about the Techlog. So what's the Techlog, and can we like using the Techlog in order to process and interpret the BLT data? So basically the Techlog here, I would say like it's a integrated platform. You can use it for multiple domains, starting from petrophysics, geomechanics, reservoir, as well as there is like a module or suite, we call it. It's for the production login. It's for the BLT. Once you click on the production logging suite, it's gonna show up for you all these options that you can use like some of them or all of them in some cases in order to interpret and process the data for the BLT. There's like a multiple options, starting from the data preparation in order to like prepare the data. And here, what I mean by preparing the data, it's splitting or organizing the data depends on the direction or flow, direction of a flow, or if we have a station also, it's going to be separated all of them. And this, we're going to see it, all this, we're going to see it inside the software. Here, the multi passes, it's used for the display the data, and as well as in order to QC. And the spinner calibration, plotting, data stacking, multi-sensor here, it's just specifically for the BLT or for the FSI or maps. You can process the data. Also, I would like to mention here that this suite or the plugin inside the software, you can use it for all the tools from different vendors, either to be SLB tools or another tools from another vendors. Also, there's like a kind of algorithm, which is automatic algorithm, such as for the spinner. There's like two options for the spinner calibration, either for the conventional way that we are using on all the softwares or even in the Excel, or there's automatic option that software gonna does it for you and compute the velocity. Here, basically, this is the complete workflow, starting from receiving data till you print the summary report. First of all, we have the data preparation here. We're gonna prepare the data, split it into like down, up, and stations. Then we're gonna, for sure, the first thing that we are doing in all the acquisition that we are receiving from the field, the first thing is the QC the data, right? So in order to QC the data, we have to display the data, right? So by clicking on this option, you're going to control which sensor that we would like to display, and for each each passes, or you're going to disallow one of the passes. So you're going to display at the end the data or the sensor that we wanna like a QC, or you are interested more in QC them. Then after you see the data and you see that all things are good, then the third, like I would say, the third workflow step, it's doing the spinner calibration. Now we are converting the RPS into the velocity by having the spinner calibration. Then we gonna identify the BVT data. And in the BVT data here, you have like two options as well. We have either like the basic BVT data, in case if you have only the basic BVT. Okay. So can you see all the view now? We just see like the chat. Can you see like all my screen for the presentations? Just please confirm. Okay, thank you. So here, fluid properties, we're gonna identify the BVT either to be the basic or advanced. In case if we have all the data from the BVT, even like the composition for the C1 till say C12. And the last one is going to be the rate calculations. So now you identified already the BVT, you compute the velocity, then all you have to do now to do like the rate calculations, just like entering the calculation, entering like all the data from the BVT, the velocity, and you're going to end up with having the rates, total rates at the surface and at the downhole, and the contribution for each zone or each perforations. Another two options. So this one, it's here. So like the rate calculation, the interpretation for the BLT is done. In case if you have like data with multiple choke sites, you can do the selective inflow performance. And the last one, which is something extra and new in the BLT suite, which is the Wellbore Performance Advisor. This one is a kind of the simulation. I have like a dedicated slide in the end. I will explain it in details. What this kind of option you can do it after done with your interpretation. So here, the data preparation, by clicking, there is like a menu options. You can choose for the data preparation for the basic, here for the sensor activation, if you would like to activate or deactivate one of the sensors, say station preparations, basis setup. This is a kind of advanced, I would say, data preparation that allow you like to assign each color or assigning like the name for each bus, tool setup, and the unit also change. And for this is showing you like if you drag and drop all the data set inside the software, what the data preparation gonna do it for you. It's prepare it, passes down here. You have all the down, you have all the up passes, and in the middle you have the stations. So this is inside the software. Just by clicking, it's going to take only like a few seconds. As you can see now, done with the data preparations. The second one is the second tool, I would say toolbox is for the multi-display. And there is kind of utilities that you can use it. Okay. Okay, just give me a minute, please. Okay, I will give like access to Mr. Mohammed just to let like the more people to join. So because he has the access, so they can join from them. Can you hear me? Can you hear me, Mr. Mohammed?
Yes, I can hear you.
Yes.
Uh,
Great.
just okay, Mr. Mohammed, you can continue, please. Thank you.
Okay, thank you. Thank you. Apologize for this interruption. Just please let me know if you can see my screen again.
Yes, it's good. Mr.
Yeah,
Mohammed.
thank you. Thank you, Mr. Mohammed. Okay, so now we're gonna continue like till we stopped here. The utilities, there's like multiple options. One of them it's converting, because like when we have the station, sometimes we have the up, down, and the stations. For the stations, because the reference for the station it's the time, and we need to convert this reference from the time till, for example, to depth. You can do it from the station to depth. Here, there is another option for the reference match. If you would like to, I would say like make the data on depth by having shifting it either up, down, or basically based on the reference gamma ray variable to flag. If here, if you have like some of the area with a bad data quality, you can flag it and remove it from your interpretation as well. Another toolbox, which is going to be like for the spinner calibration, there's two options. There's like an automatic spinner. We're going to compute the spinner for you just by entering the data set and the perforation, and going to does it for you automatically. And another way, which is the conventional way, you have to pick up like a calibration zones and then do the spinner calibration to have your velocity. The holdup here is just kind of a viewing for the holdups, to view like plotting them, and as well as if you have a capacitance or resistance, you can convert this the output from the capacitance into the holdup by having, like I would say, the reference or the calibration values that done at the surface or the workshop. Just like enter it in the software, and having the capacitance, you can convert it to the holdup in order to use it in the rate calculations. The multi-sensor, it's here, it's dedicated only for the FSI or the maps, the tool that they are using for the horizontal wells. And another toolbox here, the data stacking, that we're gonna know it more once we open the software. Here we're gonna create a data set in the data stacking that containing only the variable that we are using for the rate calculations. Here the fluid properties, to identify the BVT, and then rate calculations and another features that I have already explained. Here it's showing like the software of the Techlog. You can integrate basically all the data together. If you have open hole, case hole, cement data, and along with the PLT, you can integrate it all together, either to display it or print it. This is the slide I was talking about, which is dedicated only for the well performance advisors. I will just explain it here in this slide. It will not be covered inside the software. So this is the well performance advisor. Basically, it's gonna give you like a kind of the simulation you can do it. But what you need in order to this like a feature to be working, actually you need to have Bipsum, one of the SLB software, to be installed in your machine. But actually, you don't need to open. You just need to install the Bipsum inside the software, and then you're gonna have like the World Performance Advisor or WPA gonna be working. So here, what's gonna give you, for example, we did like the interpretation for the BLT, and when we end up with this profile that we had like 2 perforations, it's producing mainly water. So in order to do the intervention, they're gonna do the intervention inside the well site. What we can do it as interpreter, we can do a kind of simulation. Inside the software, inside the BLT suite, we're gonna plug this perforation and also close this perforation, and we're gonna see the impact of the closing these 2 perforations on the production profile, and how is impacting, for example, this last perforation on the middle perforation, because there's a kind of what they call the pressure pack might be like affecting the second or the middle perforation. So we're going to see the impact of that closing the perforation on like another perforations and production. So there is not only like closing perforation or adding purge or plug, but there's another options for the intervention, such as reperforation, adding new perforations, and also like a close batch, and another, like I would say, another features or another interventions plan. You can do it and simulate it, and at the end you can present it, and at the last you can confirm it with the real data. Also at the last, it's gonna give you like a kind of a study for the economic study. This is also done automatically. You're gonna just enter the cost for the intervention plan, and how much time is going to take for this intervention plan, and it's going to calculate it for you, how much you're going to spend in terms of the economic, and how much time you're going to return it, and how much oil you're going to lose, and what's the impact of this intervention plan of overall production and the economic rate as well. So this slide, we reached to the end of the theoretical, I would say, part of the presentation. Now I'm going to go to the software in order to do the BLT interpretation. The program or software I can. So here there's a question here. It's saying like, what's the program or the software you can use in the BLT? For this webinar, we're going to use the Techlog software in order to do the interpretation. Just please let me know if you can see the software now. Okay, thank you. So this is the software, and as you see it in inside the presentation, there's like a multiple buttons and multiple features. You can like open all of them, or basically based on your subscriptions. Here, the BLT or the production logging, or the modules, or the toolboxes that we are going to use. So what we need first, I will do it with you from scratch. Now we have here the raw data. We have basically 6 passes up and down, and we had 3 stations. What I'm going to do, I'm selecting all of them. I'm going to drag it and drop it inside the software. Under the name is Wall1, and this is all the passes, which is like in total around like 9. 6 of them it's up and down, and 3 are stations. So the first thing, we need to like organize this data in order to do the data preparation. I'm just gonna like import it inside the software. Now we have no data. Now I import it. I just need to organize it. What I mean organize it, there is an option called grouping. I'm gonna select all the passes, right click, and go to the grouping. What is this grouping? It's basically same as you are putting all your like images or PDF in one folder. Now I'm gonna put it in one folder. I'm gonna call it, for example, flowing. Flowing. It's only flowing. Okay. So now we have all the data set for the up, down, and as well as the station inside one folder, which is the flowing. The first thing I'm gonna do, it's the data preparation. The data preparation, I'm gonna prepare all the data. Okay, I'm gonna press on the flowing, this grouping, and there is here two options, either to be expressed, which is the faster one. You don't need actually to interfere like the software, while the custom you can like, there's like a more option, you can customize it by yourself. I'm gonna go now with the express. I'm just gonna write okay, and now as you can see, the data started to be prepared, and now it's done. Let me open it. So you see now we have the up buses, the down buses, and we have the stations here, and here the station to depth. So here it's already converted the station to depth. Now we have here the station, the reference is time, and here the reference is the depth. So now after we did the data preparation, which is the first one, now we need to QC this data, right? So I'm gonna display the data by clicking on the multi-display data. I'm gonna display the down, up, and the station to depth. Here, all the sensor, I can choose which the sensor I would like to display, or by having this kind of a template that you can select it. And for example, if we select the PLT basic, it's gonna select like some of the sensors, PSP basic. Yeah, for example, pressure, temperature, spinner, cable speed, gamma ray, gas holdup, water holdup. Here I don't need the bearing. And the caliber, I need the caliber average, for example. So by just press into the display or this run, before I'm gonna go with the run, there's also here like an extra options. You can use it for the viewing the data. Here is it's asking you, do you would like to see the data at the header by the name of the data set, for example, down one, gamma ray, or just a gamma ray by variable. I will go by the data set and the variable. And here also you can have the scale for each sensor. For example, let's go with the gamma ray. For this scale, I'm gonna go with the DFH from 0 to 1.2. From 0 to 1.2. The caliber, I'm gonna go with 2 to 3. I will keep it here default. Density, I'm gonna go with 1 to 1.2, let's say. Pressure, then I'm gonna go with run. Now I have displayed the data. So starting from here, what we have here, the caliber, but I believe the scale was not correct. So I'm gonna go with 3.5, from 2.5 till 3.5, or we can make it more sensitive. Okay. So there is here a lot of options. You can use it for reading, for more visualizing the data. I will go with this. It's going to be reading, and this one is going to be kind of the cross line. So the ID or it's reading around the 3.1. And here we have the DFHM, which is the water holdup, and we have the gas holdup. If you would like to display it without the grids, just select all the columns and remove the grids. And here we have the gas holdup, water holdup. I see all the buses are well overlaying on each other. It's kind of spiky, but it's overlaying on each other. Here we have the gamma ray. The cable speed is showing a consistent cable speed mainly, and this is our spinner. Is it fine? And here is the graduomanometer or the density. The pressure, it's not shown like the wall, it's very well stable. There's like separation between the passes. And the last one we have here, what we have confined, starting from the caliber is reading within the expected. And then we have the gamma ray, we have the cable speed, the spinner is working fine. The temperature is a kind of like unstable. This is indicate that the wall bore was not like a fully stable once they did the PLT passes. So I need just to enter or like visualize also the perforations. So what you can do, insert new perforations, add zone, and you can select here the perforations and you can save it. Okay, then you save it and enter the correct depth. For this exercise, I have already my perforations. This is all the perforation. There we have one perforations here, another perforation here, and the third perforations here. Also, you can have your wall schematic by just clicking on the wall schematic and entering, for example, casing or tubing, all of them. I will not enter it correctly just to save time. Just in order to visualize. This will not be entered in your computation or the interpretation. It's just a kind of visualization. You'll save it. So here I have my well schematic as well. If you have any data from another like acquisition, you can also keep it here in this layout. And if you are satisfied with this layout, you can save it. And you can find it always in the layouts here. So now I'm okay with the data visualization. I'm done with the data QC. The next operation or the next step is going to be the spinner calibration, right? So before we proceeding with the spinner calibration, as I mentioned, there's like two options. First, I'm going to go with the conventional way, and then I will show you the automatic spinner calibration. So what I need to do first, I need to insert a calibration zones, right? First, in order to determine the threshold, as you know, it's gonna determine for you the minimum speed that the spinner is needing to start rotating. Okay, so basically here either to be taken from the manual of the BLT, but it's always better to measure it by the tool in the no flow area, which is here below just the perforation. So we need to have one calibration zone here. Another calibration maybe between the perforations, one here and one here, or one here and another here. It's in the calibration zone that gonna calculate the velocity at the calibration zone, and the velocity below the perforation is gonna represent your threshold. So this is the calibration zone that we can take one here, another one here, and another one here, and the last one maybe above. You can go with a three or minimum, I would say like a 3 for this case. 2, it might working, but here for sure it's going to be in one calibration zone and one above all the perforations, and better to keep between the perforations. So now I have my calibration zones, I have the perforations, I satisfied with the data QC. Then I'm going to go now for the next step, which is going to be the spinner calibration. We close this one. Spinner calibration. So in the spinner calibration, I need the spinner and the cable speed. I'm gonna go with the create. I'm gonna go now and I drag and drop all the data set for the up and down. In the zonation, I need to insert my calibration zones. I go to the global zonation. I had like 4 calibration zones. I'm gonna insert it here. And then in the calibration, here you have, and once you run, you have either to display or save and display. The first one, it will not like save it in your data set. It's just gonna display it for you. So as I click run, it's gonna show it for me the plots for the spinner calibrations and also what the layout for the computed velocity, which is this one. So as you can see, it's all overlaying on each other, indicating like the velocity is matching. But what I need now is to having my threshold and apply it maybe on the another computation or the calibration zone. So I know that this zone, which is zone number 3, which is just below the bottom perforation, is there is no flow, right? Which is this one. There is no flow. So I know the flow here is 0. So what I'm gonna do here, I'm gonna force, or I'm right here 0. So this is my negative threshold, and this is my positive threshold. I'm just gonna apply it on the another calibration zones. Fill up. And then I'm gonna go now with a save and display in order to save it in my data sets. I'm gonna see this is my plot, and this is my computed velocity. This is the profile shown good. For the plot, you can disallow, like for example, some of the passes by just clicking on it. By just click on this one, it's going to be disallowed. It will not be entered in your computations. And so on for another, like passes for another, like spinner calibrations. So now I'm done with the spinner calibration. So if I search for the V app, which is the spinner velocity, I'm going to see it on all the passes. So I'm just need to now close it. I don't need for this one anymore. So now I did the spinner calibration. I finished the spinner calibration for the conventional way. So the next, I will just want to show for you like the automatic velocity. In this one, you don't need actually to have your calibration zone. You just need to drag and drop your data set, and then go to the main. Here you have already the spinner and maybe the cable speed. You're gonna choose it. In the auto, you're gonna just identify your perforations, which is this one, and then click on run. So you see here it's also computed for you, the profile for the velocity and the velocity. So this is the automatic options, and there is like a conventional way for having the spinner calibration by first identifying the threshold, then apply it, and you have the plot. You can control everything. And here no, it's just like automatic. You can control only like the zone size, which is the zone for the calibrations. That's the software gonna does it for you, and the default threshold. This is the default threshold. You can take it from the manual for the each PLT or for each spinner. Depends on what type of the spinner that you are using. Is it like turbine? Is it like inline? Is it like a full bore spinner? What's the size of it? Each one, it has like a specific value for the threshold. So now we did the, no, I wanted this one. Now we did the spinner calibrations. Now what we need to do is the next step is this data stacking. So what's the data stacking? In the data stacking, I'm gonna create a data set, same as like one of the passes, but it will be only one pass that I'm gonna use it in my rate calculations. Okay. And this data stacking, it will be basically depends on your QC. So once you did your QC, for example, in the on the water holdup or the gas holdup, you're gonna go only with the down passes. You will just remove the up passes. You will not enter it in your computations. Temperature, as you know, it's highly recommended to go with the first down pass. The density or also even like holdups, it's recommended to go with the down passes. The caliber, it's the opposite. It's recommended to go with the up passes, and so on. So now you can control all the passes that you need to include in your interpretation or include in your final data set. So I'm gonna call it here data set stacking is the final data sets. So I'm just gonna press on the data set stacking. I'm gonna drag and drop all my up and down passes. Yeah, just give me like maybe extra 4 minutes or 5 minutes. Okay, so in the main, I'm gonna go with the basics. Here, the average density, gas holdup, water holdup gamma, I don't need it. The caliber, I'm gonna go with the average caliber. Then apparent velocity for sure, pressure, temperature. This is for all sure. Okay, so now all we have it. You can here choose, for example, the DFH, and you can control which buses that we want to include by, if you don't want to include or disallow, just instead of 1, keep it like, for example, 0, 0, 0, 0. I'm just gonna, just to save time, I'm gonna just go with all the buses. So when you press save and display, you're gonna have your data stacking. The data stacking, which is the black line, which is gonna take the average of the buses that you have included. Okay. So now we did the data stacking. There are 2 steps more, which is the identify the fluid properties and the rate calculations. Identify the fluid properties by just click on the fluid properties. So once we did the data stacking, you should see another data set in your browser here, which is called the stack. Now I'm gonna identify my BVD data. I'm gonna drag and drop the data set for the stacking. In the main, I have here, since I know what I have water and hydrocarbon. I don't have oil, I have a dry gas. I'm gonna go with the maybe 30 ppm. This would be taken by from the BVT from the field. I'm gonna go now save. Now I have identified my BVT data, and you can see here a fluid properties grouping it's appearing. Now we almost done with the interpretation. We just need to do the rate calculations. So I'm gonna press the rate calculation. So here you're gonna control which parameters or which sensor you want to include in your interpretations. The minimum is gonna be temperature, pressure, the caliber. If you don't have the caliber, it's fine. You can use the fixed value, as well as the hold up and the gas hold up. Or if you don't have both of them and you have 2 phases, it's enough of having the density. I'm gonna go now create. I'm gonna drag and drop. I will not drag and drop all my up and down buses. No, because I have already now my final data set. I'm just gonna drag it and drop it here. In the general, here is asking you for the temperature, would you like to use like a specific value, or you take it from the BLT from the sensors? I'm gonna go with a use variable for the pressure. For the hole diameter, if you don't have like a caliber, you can use a constant value. For the fluid properties, we have already identified. For the flow zones, I'm gonna go first with my perforations. Then maybe I'm gonna split it in order to have a better match. So now I almost done. I'm just need to press run. So this is my profile and this is my match. And it's gonna show us also like a table for the rates. Here the units, I did not change it. Here it's basically in English. You can convert it in the barrel per day. It's gonna give you like the surface rate and the downhole rate for the water, for the gas as well, and if there is an oil, you can identify it, and for each perforations. And this is my match for the velocity. This is my match for the hold up. I just need to make it the scale more representative. Here, you see it's for the water, it's matching perfectly, and here it's also matching perfectly. For the velocity, you can work on it as well, because I include my inflow zone as the calibration zones. But what you can do more is like splitting this, splitting the perforation. For example, I'm gonna split maybe this one into like 3 inflow zones. Then save it. Then, for example, run it again. You can have, for example, a better match. So you see now? No, so it's much better than previous one. So you can work on it till like you have like optimized case. Same as for this for the last perforation, you can split it in order to have a better match. But overall, the match is looking perfect. Even like above the perforation, it's very well matching between the modeled velocity and the computed velocity, and as well as for the holdup for the gas and for the oil. And now you have the holdups and the flow profile from each perforations, and as well as the type of the fluid and how much of fluid that you are producing for oil, 0 for water, and as well as for gas, since this a well gas. So till here we reached almost to the end of this webinar. I would like to thanks a lot for your kind like attention and patience, and please let me know if you have any questions. And
Okay,
also,
thank you, Mr.
go ahead.
Mohammed. There is some questions in the chat box. You can read them and answer, please. And
Yes, sure.
if anybody want to talk, you can give him or her a permission from your side too. Thank you.
Sure, sure. Thank you, Mr. Mohammed. So I'm gonna start for the questions. Okay. So what's the program or the software we can use in the PLT? So there are like a variety of programs that you can use for the PLT. Basically, or not like basically each one maybe have like an advantage or limitations. For this webinar, as I mentioned, we focused on using the Techlog on the interpreting the PLT data from different vendors, and also not on the PLT data, you can use it for the another like the data maybe like from the different vendors. Another question, can we compute apparent permeability by PLT with Techlog? So what do you mean like here by, I did not get your point by like calculating apparent permeability by Techlog. The Techlog, sorry, the PLT, it's, you know, like basically it has like some of the sensor which is working mechanically, such as the spinner, and another one which is like sensors such as the hold up and the density. But from the output, once you're done with your like results or the interpretation and processing, there's a kind of the workflow that you can use it in order to estimate the permeability. Yes, there's a kind of the workflow and software as well, plugins, dedicated plugins. You cannot use it here in this plugin. There is no feature in order to identify or estimate the permeability from the PLT results. Okay. What's the famous program or software we use in the PLT? There's a lot of softwares, Mrs. Yuna. So there's a lot of softwares. I mean, as I mentioned, and each one maybe like has a specific like features, and all of them like are gonna give you like a results, but basically it depends on your Pythons and the algorithm of each software. Recommend a book to read about the PLT. Okay, so Muntadar here is asking about like can I recommend like a book to read about the PLT? So there's like one of the books that I have read before once I joined the company. It's called like The Fundamental of the Production Logging. Basically, it has all the fundamental, even the advanced stuff for the PLTs, for production logging, and each the sensor, and even the mechanism of the sensor, how is working, and what is like I would say, what is the like the readings, or like how is measuring or how is computing the like till you get like the output result. For example, the density, how is working, what's the principle of the working of the density, what's the limitation of each one. But at the end of the day, these books, as you know, it's gonna give you only the theoretical part, right? So once you have the theoretical part, which is, I would say, it's essential things, but always like it's gonna come when you do your interpretation by your side. It's gonna depend on your experience and your hands-on. So basically, based on your experience, and gonna improve more and more and more. But for sure, the theoretical, it's very, very important. Thanks a lot, Mohammed.
Okay, thank you,
You are
Mr.
welcome.
Mohammed. Okay. At the end of our webinar, if we don't have any question, maybe one question from Mr.
Yes.
Abbas Radi.
Yes. So here
can-
is asking regarding the project result from Techlog, for Techlog can open it in Kappa. So here it's gonna be depends on how you are exporting the data for the results. You have multiple options, either to export in the last DLS, geolog ASC file, format, text file, and the DLS or the XML. Here the XML is only working for the Techlog. So what you can do in order to, I would say, like exporting into like another softwares, either to export your results in DLS or in the last format. These two like format is gonna work for all the softwares, because this is a kind of a standard, I would say, format for the data. You can export it either to be DLS or the last, and you can have it in your another software. And no, for the KE2 file, you cannot export it from the Techlog, from the Emerald to Techlog. It's only exporting last DLS and this format that you are seeing here. I will just like maybe take a snapshot. If I can, yes. So these formats, you can export it. And for the import, you can import also the same as well as Excel file. But for the KE2, we cannot open it inside the Techlog. More than welcome. Thank you, Hussein. Thank you.
Okay, Mr. Mohammed, if we don't have more questions, and there's one note about the attendance link, we will send you a certificate during 3 days. So all of the attendees here, they will receiving a certificate. At the ending of our webinar, Mr. Mohammed, can you make me a host, please?
Yeah, sure. Just give me a minute. So the floor is yours, Mr. Mohammed.
Okay, thank you, Mr. Mohammed. Dear attendees, we value your feedback on LinkedIn. I will send you the link, please. We will wait your feedback. I will send you the link on the chat box. You can find it. And we would like, as SPWLA Chapter Iraq, to thank all of you for joining us today. We hope you found this session informative and valuable. Hope to see you in future events. And thank you, Mr. Mohammed Alsmael, for your informative presentation. Have a nice time and bye-bye.
Thank you, Mr. Mohammed, and thanks you, Mr. Mazen. Thanks a lot to all attendees for joining this session, and I hope to see you again in the future. So thanks a lot, and have a good day.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.